Hello, my name is Jac Cross and I'm part of the developer team for Oasys Post. And today's webinar will introduce the new features in version 15 of D3PLOT and THIS. So version 15 was released in May this year, and it includes various new features to improve the user experience, to improve integration between Primer, D3PLOT and THIS, to improve the graphical output from D3PLOT, and the packages continue to support new advanced functionality in LS-DYNA. So I'm going to run through the main new features in turn, and the first thing I would like to talk about is called Quick Find. So Quick Find is a new and easy way to access THIS and D3PLOT functionality from one place. So it's a useful tool if you want to use functionality and you don't know where to look, and potentially a quick way if you're an experienced user to access functionality as well. So Quick Find is accessed by pressing the magnifying glass icon in the right-hand panel, or by pressing the hash shortcut key. When you do this, you'll get a Quick Find text box come up, and if you type into that text box, then Quick Find will bring up a list of functionality that matches your search text, and you can then select from that list and open up the particular menu that you need. So let's have a quick demonstration of Quick Find. So I'll open up a THIS session, and you can see that we've read in one curve into this THIS session. Now, if we wanted to calculate the HiTec value for the curve, we can use Quick Find to help us get to that function quickly. So we can press the magnifying glass icon below the Tools menu, and you'll see that brings up the text box. If we simply type in HiTec, you'll see that Quick Find has found various functions or various menus which match that search text. And at the top of the list, we've got Tools Automotive HiTec, which is the menu that we would need to calculate the HiTec value. Quick Find uses a fuzzy search, so it finds items that have characters in the same order as the characters that you type into the Quick Find text box. So if I press the magnifying glass icon again, and I just type in TU, you'll see that as well as finding a menu that's got TU in tutorials, it also finds tools units, the third item on the list. So it matches the order of the TU we typed in to search strings that have the same characters in the same order. And you could move down to that, so move the highlighted menu down with the arrow keys and press enter to open up the tools units menu. Quick Find also searches alternative text. So if I press the hash key and type, and say I wanted to annotate the curve maximum value in the graph legend, I might type in max. And what you can see here is that we've found tools operate max, which is not what we need. What we actually need is tools properties legend, and that has also been found, although there's no max in the menu path. The alternative search text, which is written underneath the menu path, is show maximum value on legend. So that's a way of helping to find functionality that's not necessarily obvious from the menu names. Quick Find can also be used to search in a couple of other categories as well as the menus. The first one is in tutorials, which have been added in version 15. So in the help menu under tutorials, you can see that there are a number of tutorials which have been added into THIS, and there's a similar feature in D3PLOT. And Quick Find will also search through those tutorials. So if I press hash, and if I was interested in reading results, I might type in read results. And what you see is that Quick Find has found the tutorial for reading and plotting results. And if we press that, we open up a PDF file with some guidance on how to do that. And finally, the other place where Quick Find works is in the Preferences editor. So if I go to Options, Edit Preferences, you'll see that there is a search text box, and I can type into this to use Quick Find to search through the preferences. So for example, if I wanted to find the preference for making grid lines grey, I might type in grid, and you can see that that's brought up a list of various preferences to do with the grid lines. And setting grid color is the second one on the list, which we can click on to go to that preference. Quick Find is also available in D3PLOT and Primer, and it works in pretty much the same way in both of those programs. If we now go back to the presentation. So the next thing I'd like to talk about are a collection of enhancements to the way that you can display data and view models in D3PLOT. These are best shown by way of a demonstration. So I will go into D3PLOT now to show you what's been done there. So the first thing we'll look at is the new color menu. So in Tools, Color, this is a new menu which has been consolidated from a couple of menus in previous versions of D3PLOT. And the aim there has been to provide all the most common options under a single menu. So the text color can be set in this pop-out menu here, the background color in this pop-out menu here, and there's a new option to set a faded background. So if I show you that's the solid background that you'll be familiar with from version 14. If I press the faded radio button here and redraw, you can see that the background color has been faded from the top to the bottom. By default, the bottom color is just a darker version of the top color. You can change that with this pop out to be a different color if you'd like. And you can easily reverse those colors with the reverse button here. So we'll go back to auto there. There are also some changes in contouring in the data menu. So if we look at the contouring menu, the data menu, and if I select the last state for this model, and we'll do a contour plot here, and you can see the 13 contour levels that you'll be familiar with from version 14. And if we look in the Levels tab at the bottom of the right-hand menu here, you'll see the Levels slider now extends up to 16 contour levels. So we can now plot data components with an extended contour ramp. In version 15, we also have a new option with contouring called Automatic Transparency. So in the Levels tab, about halfway down, you can see the button that says Auto Transparency. If we press that, it brings up a new panel. We can activate Auto Transparency by clicking on this tick box here. And if I replot that, what you'll see is that the contour plot now looks quite different. What's happened is D3PLOT has automatically adjusted the transparency of the contoured entities based on their data value. So the entities which are contoured with an opaque color are the ones with the largest magnitude minimum principal stress in this case. So and all of the other elements with low values have been made very transparent, so you don't see them. Now we think this is available in CT, SI, and cloud plots, and we think it will be useful as a way of making it easier to see the areas of interest within data plots. So, for example, in this case, we quickly see that the most highly stressed region of the vehicle is within the door. You don't see that when although you would know that that was the case, you don't see that when transparency is off because the inside of the door is hidden. So if I reactivate that. Now, there are various options for controlling how automatic transparency plots look. So firstly, we can adjust how the transparency varies with the data value. This is indicated in the small graph here. So we can change the transparency ramp to be based on magnitude. So that might be most suited to something like, for example, X stress, where we're interested in both the maximum and the minimum values. We can base the variation on a min to max, so that we only so that the opaque entities are those with the highest positive values. That would obviously be suited to something like, for example, von Mises stress, where it's the positive values that we're interested in. And we can also change the ramp from max to min. So for example, if we were looking at minimum principal stress, the min to max isn't really of interest, but because it's the negative values we're interested in, so if we swap to max to min, you can see that we see the information we would be interested in. We can also vary the order of the transparency ramp between a linear variation up to a fourth order variation. And what this basically does is it varies how much the plot is visually weighted towards the extreme values. So a linear variation, if we swap that from our quadratic variation, means that we see elements across a reasonably wide band of the contour ramp. Whereas if I increase that to fourth order, what you'll see is that it's only the very highest stressed elements which show up on the plot in the door. And finally, there are 3 text boxes at the bottom of this panel which allow you to set the bounds for the minimum and the maximum transparency or opacity of the elements, and also set the opacity of the uncontoured items. So you can control the way that the plots look using those as well. Now, if we go back to the main contour menu, you'll see that also there's a new button at the bottom of this panel called Save Contour Colors. Now, what that button does is it saves the current contour colors to your OA pref file. So this would be useful if you regularly change the default contour colors. So for example, if you set the minimum contour band to be gray, because then your modified contour ramp will be restored each time you open up D3PLOT. Okay, we'll now go back to the presentation and move on to the next feature which has been added, and that is improved integration with pre-processing. So with the Oasys products, D3PLOT, THIS, and Primer, you would traditionally look at LS-DYNA input files and results files separately, although we recognize that it's often desirable to be able to access both sets of data at the same time. So for example, if you're looking at results, you may want to look at the material properties for a part that has failed to see what they are. Or if you're looking at changing your model, you may want to see how it failed in its current configuration to guide how you apply the changes. So in version 15 of the Oasys software, there's now the facility to open Primer or THIS and D3PLOT from the other software packages, making this process of switching between input data and results easier. So this diagram summarizes the links that are now available in version 15. So the link between THIS and D3PLOT has been present for some time, and you're probably familiar with it. New in version 15 are the shared memory links between D3PLOT and Primer and between THIS and Primer. And those links allow the sharing of, for example, viewing attributes and cut sections between D3PLOT and Primer, and curve information between THIS and Primer. So we'll look at an example in the PowerPoint, and then I'll show you a short demonstration of this new functionality. So say you are looking at a model, looking at the results of your model in D3PLOT, and you want to view the input data related to the model. You can press the new primer button, which is above the tools menu here, and that will open the preprocessor panel, and you can then press start primer, and that will open up primer in a linked mode. Now you can do something similar from THIS to open primer, and equally from primer you can do something very similar to open either THIS or D3PLOT. So when you press this start primer button, primer opens automatically and reads the keyword file and synchronizes the view and the blanking status of the model. So in the PowerPoint you can see this is illustrated on dual monitors, and that's how you would get the best experience out of this new feature. If you blank some parts in D3PLOT, the blanking is automatically applied in the primer window as well. And if you change the view in D3PLOT, then the view is synchronized in the primer window as well. So let's take a look at a demo of this. So we'll go back to this vehicle model. So say we're in D3PLOT looking at the vehicle model, and we'd like to also look at the input data. So we can press the new primer button above the tools menu here, and that opens up this preprocessor panel. Now, in this case, D3PLOT has automatically found the keyword file, and it says in here, keyword file available. And that means we can start primer straight away. If D3PLOT hadn't been able to find the keyword file, you would have the option to manually browse to it. We can also, using these tick boxes, control which aspects of viewing and so on are synchronized between the two programs. In this case, we'll leave them all ticked. So we press the Start Primer button. That's opening up Primer. And what you'll see once the model is opened is that the viewing and the blanking will be matched between Primer and D3PLOT. And I'll put them side by side in a second so we can see that more easily. So here we've got the two models side by side. We can see that the viewing and the blanking is the same. Now, in D3PLOT, if I rotate the vehicle, you should see that it also rotates in Primer. If I blank some parts in D3PLOT, those parts are also blanked in Primer. I can create a cut section in D3PLOT. So if I pick a node in D3PLOT, then I have a cut section in D3PLOT, and that's mirrored again in Primer. Similarly, I can make changes to the view in Primer, and those will be mirrored in D3PLOT. So if I select a single part in Primer, and for example, go to the attached menu, and we'll find by attached parts. Now, if I hit the J key to do a find attached on this part, we'll see that the view updates in both D3PLOT and Primer. What we can also do from D3PLOT is we can access some functionality in Primer from D3PLOT. So if I right click on a part here, you'll see that there are some options here with Primer icons next to them. Now so if I hit edit, that brings up the modify parts panel in Primer for editing that particular part. If I hit the part table button, likewise I get the part table in Primer. And similarly, I can calculate mass properties in Primer for that part and look at the contact information for that part in Primer. And then when we're finished, we can close Primer if we want to. closes down the link, but leaves D3PLOT open and running. So also to do with integration of software, we've made some improvements to the THIS link from D3PLOT. And again, I think these are easiest to look at from a demo. So I will go to a D3PLOT model. So we've got the D3PLOT model open, and for some time you've been able to run THIS from within D3PLOT using the THIS link. And you do that by pressing the THIS button above the Tools menu. And when you do this, this automatically launches THIS, which then receives a list of the currently opened models and opens them automatically, ready for reading data. The THIS menus and graphs appear within the D3PLOT session, as you can see here. And then you'd be ready to work simultaneously on THIS and D3PLOT. Now, in previous versions, you would need to, you could do some work within THIS, and then you have to swap to D3PLOT menus at the top by pressing the D3PLOT button. Then you could go on and do some operations in D3PLOT, and you may need to swap back to THIS and so on. And that could slow down your post-processing. So now we have this new button next to the THIS button above the Tools menu, which says Undock THIS. If we look at that, it gives us the option to either undock the menus or undock all of the THIS components of the window, and they become a floating window which you can then put wherever you want. So if we say undock menus, we get the floating THIS menu here. We can redock that by pressing the Dock THIS button above the Tools menu. And we can alternatively undock all of the THIS components, and then we would be able to put this easily into a second monitor, for example, to help with our post-processing. So hopefully that will be a useful new feature for you. So back to the presentation. The next thing I'm going to talk about is enhanced support for plotting results in material axes coordinate systems. So LS-DYNA by default writes results to the PTF files in the global coordinate system. And in existing versions of D3PLOT, D3PLOT can transform those results into other coordinate systems, which you do by selecting on the drop-down menu in the reference frame part of the data menu. So for example, you could select user-defined coordinates. You can change the results axis system that DYNA outputs to by setting conflag equal to 1 on the database extent binary card. And if you do this, then DYNA will output results for elements that are of an orthotropic material in the material axis coordinate system instead of the global system. The issue with this is that nothing else in the PTF file changes to indicate that this has happened. So post-processors can't correctly interpret these results based on just the PTF files. So they would assume that the results were in the global system, and this is the case in D3PLOT version 14. So it's been up to the user to correctly interpret the results based on their knowledge of what the value of conflag is set to. And that can get a bit tricky. LS-DYNA has quite a number of options for defining material axes, and some of these options are additive, and some of them overwrite one another. So it's actually not a straightforward task to calculate what material axes for a particular element are. The version 15 Primer now supports all these rules, and that means Primer is able to write all the information that D3PLOT needs to deal with material axes into the ZTF file. So the ZTF file now contains the conflag value, the material axis systems, and the material for each element and each integration point. And what this means is that So long as you've got a version 15 ZTF file, D3PLOT can now correctly interpret the results when conf flag is set to 1. And what it will do is it will automatically transform stress and strain results back into the global coordinate system. So the plots on this slide just show the same model. On the left, the model was run with conf flag of 0, and on the right, it was run with conf flag equal to 1. And you can see that the plots are identical, which is a demonstration that D3plot has been able to automatically detect the correct way to interpret the results, even though some of them are output in the material axes for the model on the right. What this also means is that D3plot is able to plot results in the material axes based on the information in the ZTF file. So if D3plot detects a model with orthotropic materials, it now offers you the option in the ref frame drop-down menu to plot in material axes. And that will be the case whether you've got conf flag set to 0 or to 1. So hopefully that will make it easier to deal with material axes. The next feature is also to do with materials, and it's to do with improved support for extra data for materials. So some materials in Dyna can output extra variables to the PTF file if you set the parameters NEI-PH or NEI-PS on the database extent binary card. And in earlier versions of D3plot, we've supported these extra variables, but with some limitations. So this slide illustrates two of those. Firstly, elements that do not output the selected extra variable would still be contoured. So they'd be contoured with a value of 0. So for example, in this image, the dark blue parts that you can see at one end of this component are actually a rigid material, which doesn't output the selected extra variable. And so they're contoured with a 0, but it does make it more difficult to see which parts of the model are showing real data. Secondly, the extra variable component name is generic. So in this example, we're just showing solid extra 7, and that makes it obviously much less clear what physical quantity is being plotted. And then finally, elements with different materials that use the same selected extra variable are contoured together, even if that variable represents different things, which can make it difficult to interpret the plot. So in the image you can see here, there are 3 materials that all use component solid extra 5, but for each material it represents a different physical quantity. So that makes that kind of contour plot quite difficult to interpret. So in D3plot 15, we've enhanced the support for these extra variables to address these issues, and I'll just demonstrate what we've done. So the model you can see is a welding analysis, and it uses MAT CWM for the green plate, the red plate, and the welds, and it uses MAT rigid for the clamp at the end. Now, if we go to the category menu, you can see the extra category, which has been available in earlier versions of D3plot and lists the generic components. So in this case, we've got solid extra 1 through to solid extra 12. In version 15, if we go all the way down to the bottom of this components, of this category menu, you can see material properties category, and within the material properties category, we've got a list of components. Now, to populate this list of components, what D3plot's done is it's identified from the ZTF file what materials are available in the model. So you do need that ZTF file to be able to use this functionality. It's then picked up the extra variable names for each of the materials from a pre-populated CSV file, which is included in the installation package. So the good thing about this being a CSV file is it means that you as a user can edit it, and that would enable you to accommodate new materials, for example, by adding to it, or to modify the component names if you have a preferred name for a particular component. And then the components are arranged by material. So if we had several materials with extra components, then we would get several sublists in that category. So I'm going to select solid temperature last and plot that data so we can see also how the plotting has been updated. So what you can see is that D3plot has identified in this model which parts are of MAT 270, MAT CWM, which is correctly the welds and the two main plates. And it's contoured those, but it contours in grey or renders in grey the parts which aren't from that material. So the rigid parts forming the clamp are rendered in grey, which makes it much easier to interpret this plot and understand what actually has real data on it. And then the other thing is that the component name above the contour bar is the meaningful name from the category list, rather than just solid extra 5. So going back to the presentation again, the next new feature in version 15, again in D3plot, is support for multi-integration point solid elements. And this follows on from the capability that was added in version 14 to plot on-plan integration points for shells. So individual integration point values for solid elements with multiple integration points can be written to the results files by LS-DYNA by setting n-int solid on the database extent binary card to 8. Now, in previous versions of D3plot, even if you did this, D3plot would then automatically average those values on reading the results to a single point at the center of the element. And so it wasn't possible to view the variation of data across an element in D3plot. So in version 15, you can now look at these individual values. You do need a ZTF file so that D3plot can pick up the section information. So the plotting of integration point data for solid elements is controlled with the existing pop-up on the data menu. So that's this pop-up here next to integration point, which was previously only for setting how on-plan integration points were dealt with. And you can set that to either be all the points separately, in which case you can see the variation of data across an element as shown by the image at the top on the right, or you can set it to average at center, in which case the multiple integration points are averaged and you get a single constant value across the whole element, as you can see at the bottom. And that's what you would see in version 14. So by plotting all of the integration points, you better pick up the peak stresses in the model. So just as by way of an illustration of this, the image on the left, these two images show the same model. The image on the left is showing results averaged at center, and that gives a minimum stress of minus 396. Whereas on the right-hand side, we're showing the same model, and we've set the integration points to all points separately. We can see that the minimum has gone to minus 417, so sort of a 5% increase in that test case. The right menu has also been updated to support multiple integration point results for solid elements. Control over how the integration points results are output to the table is via the integration point drop-down, the right-hand one. And you can select all points separately, average at center, or you can select from any of the individual integration points. And then when you when you generate the right table, that will show values at all of the valid integration points, and it will show not applicable at any integration points which aren't valid. So in this example, we can see that the element here, H321, is a single integration point solid, and so we have not applicable in most of the integration point slots. And similarly, the XY data menu has also been updated to support multiple integration point solids. Selection of which integration points to plot is the same as for the right menu, and what you'll find is that the graph just shows the valid integration points, and then you get those appended to the curve title in the legend, so you can see what's what. Okay, so the next feature is an improvement to the part-to-part measure tool. So D3PLOT version 14 can measure part-to-part distance as shown on the left here, and what you get is a line indicating the minimum distance and an annotation telling you the size of the separation. In version 15, we've added the capability to contour plot that part-to-part distance, as you can see on the right. What I'll do is demonstrate this new part-to-part measure tool. So here we've got a model of a front impact, and we might be interested in the separation between the passenger head and the dashboard. So we can go to the measure menu in the tools panel, and we can click on part-to-part measure, and then we can select the passenger head and the dashboard part here, and we get the version 14 style line with the annotation. Now at the bottom of the measure menu, you can see that there's a new part of the panel here, which is contour part to part. Now the part-to-part distance can be contoured by turning on contouring using this tick button, and then pressing recalculate SI. What that does is calculates the contours based on the distance from each node to the nearest segment on the opposing part, and then contours that across the two parts. We can also plot that as a vector plot using recalculate vec. What that does is you've got the same contours, but with the addition of an arrow indicating the direction to the nearest segment on the opposing part. We can also animate the model with the part-to-part distance contours active. So that would work. I won't do that now just because of the sort of slight delay in calculating that. And then there are some further options. So in addition to contouring the distance between two parts, we can also add parts to either side of the measurement. So down at the bottom here, you can see there's a parts tab. We can select which side we want to add parts to. So if we select side 2, and then we say add, and then we can use the object menu to select perhaps the rest of the dashboard so that we get a more comprehensive measurement. And then we press apply up at the top here. And you can see that the contours have now been calculated across the multiple parts on side 2. If we click on the options tab, we can choose which sides of the part-to-part measure to contour. So we can turn off either side 1 by unticking side 1, or we can just plot on side 1 by unticking side 2. We could also use the options here. So one is to subtract the shell thickness from the distance calculated. So there may be cases where the shell thickness is important. And there's another option called die closure, which is which only contours nodes where the vector from the node to the nearest segment on the opposing part is within 10 degrees of the node normal. And that would be something that might be of interest if you were doing a die closure analysis. So the next tool which has been updated is the attached tool. So we've extended the types of attachment through which you can find attached elements. So the new attachment types are nodal rigid bodies, constrained joints, constrained rigid bodies, and tied contacts, which now appear at the bottom of the menu, highlighted in red there. So the information for D3PLOT to identify these new attachment types has been added to the ZTF file. So again, you will need a ZTF file generated with version 15 of Primer for those to be available. In general, the attached panel looks, I think, the same as in earlier versions of D3PLOT, but there is a new option for finding rigid body parts, which is similar to what's available in Primer. So if you find attached rigid parts with using whole part rather than single elements, then in one go you'll find all the elements belonging to that or of that rigid material, and that includes the case where you've got a non-contiguous mesh, which previously wouldn't have been found. And then the final minor change to the attached menu is that the shortcut key has been set to default to applying the current settings in the attached menu, and that's for consistency with Primer. And if you wanted the old D3PLOT behavior, you can switch back to that by editing your OA-pref file. Right, the next feature is improved support for sets in D3PLOT. So we've added support for set definitions as shown on this slide. So parts, beams, shells, discrete, nodes, solids, and thick shells. And you can use those definitions within various of the menus. So quick pick, write, the part tree, blank, and XY data. The definitions are read from the ZTF file. So again, you do need a version 15 ZTF file. So I'll just show you a quick demo of how we can now use sets. So here we've got a sled test model, and we've got the version 15 ZTF file with this model, and that contains some set definitions. So if I go to the blanking menu, you'll see that within the object menu, we now have set part, set node, and set shell objects available. So if I select set part, you'll see a list of all the part sets in the model, and we can select the first one and blank that part set. So we can also access sets with the quick pick. So if I quick pick the dummy foot, we get a fairly common situation, which is that a particular part of the model is in more than one part set, but we can select the nearest part set and we can apply blanking to that. So the right and XY data menus also support set definitions. So if I go to the right menu and I say entity, and then again you can see the object menu contains the sets which are in this model. So again, if I say set part and I select the first set and then press apply, what you'll notice is that we're at the first state, so everything is 0. But the important point to notice is that we get an entry in the rights table for each member of the set. So for each part in that part set, we're getting a row in the table. And then finally, if we look at the part tree, you can see that by default, set definitions aren't present in this part tree, but we can switch them on by this drop-down menu type, and then there's a set subcategory, and we can select the set types that we want to view in the part tree. So if I say set part, you can see that we've now got a row in the part tree called set part. We can expand that to see all the part sets, and we can interact with those in a similar way to other items in the part tree. So blanking, for example. So that brings me on to, I think, the final part of the final item in the presentation, which is enhanced rendering. This again is in D3PLOT. So we know from having spoken to users that being able to produce high quality graphical output is important. So we've begun to develop a ray traced image capability in D3PLOT. So in the images menu, you'll now find a new image type called ray trace, which is up at the top right here. And if you press ray trace, you'll get this new panel appear, which has various options relevant to producing ray traced images. So ray tracing in D3PLOT uses the POVray ray tracer. And the POVray executable can be downloaded for free. So to generate ray traced images, D3PLOT, you need to download this, and D3PLOT needs to be pointed to where that executable is in this exec text box here. You also need to set ray tracing material properties. So these are different from the material properties that you have in the input deck, and they relate instead to things like the color and the texture of the materials that you want to render. And they're defined in a text file, which is specified in the matlib text box here. Now there is a basic set of material properties which is in a pre-populated text file which is provided with D3PLOT version 15, and you can edit that to add further materials or to refine the existing materials if you want to. And then it's also necessary to provide some rules to D3PLOT for assigning the ray tracing material properties to the parts in your model. So these rules are quite flexible, and there's a syntax for writing them, which is defined, and you can look in the manual to understand how to do that. So once you've set this input data, then you are ready to press the ray trace button. And when you do that, I won't do it here because it takes some time to generate a ray traced image. D3PLOT will automatically will automatically write an input file for POVray. It will then run POVray with that input file to generate the image. And so it's a sort of process that's carried out entirely within D3PLOT. So I'll show you a couple of images to give you an idea of the kind of results you would get. So this first image is produced using the standard images menu in D3PLOT. And then on the next slide, we'll see this is the same image, which has been rendered using the new ray tracing tool. So at the moment, ray tracing works in D3PLOT for shaded images, but this is something we're looking to develop further in the future. So that's the end of the new features. So thank you very much for listening. I'm going to check whether we have any questions that have been submitted, and I'll go through those if there have been. So I can see a question. So the first question is, will the new pre-post integration eliminate the hanging of current D3PLOT and THIS when running in a batch mode? I don't know the particular bug that you're referring to, I'm afraid. I think that that is probably something to log with dyna.support as a question, and we can then get back to you having investigated the issue that you're having. The second question is, can we write one script to run D3PLOT and THIS at the same time? The enhancements that have been put in last year wouldn't enable you to do this. I know that scripting is something which is a focus for us this year. So I will pass that request on to my colleague for consideration for the next version of D3PLOT and THIS. And then there's another question, which is, can we see the contour plots simultaneously in Primer and as well as D3PLOT? The answer to that question is no, not at the moment. The integration between Primer and THIS and Primer and D3PLOT is something which has been added in version 15, but we are very much committed to continuing to develop that integration. So it's useful to hear suggestions from users about the ways in which they would find it useful for that integration to develop. So what I'll do is I'll note down that particular suggestion, that it would be useful to be able to see contour plots in Primer as well as in D3PLOT. So I think that covers the questions that we had. So thank you very much for your time. Thank you very much for your questions. As you can see on the last slide here, if you've got any further questions, there's more information on the website, which is www.arup.com/dyna. And if you think of any further questions, and for the couple of things I mentioned just then that would be worth logging with dyna.support, if you could email your local distributor at the addresses shown on the slide here, that would be great. So yes, thank you very much. That's the end of this webinar.